Okay, now we'll explain binarization using a very small example. So, first of all, why are we asking you to do binarization by hand, or to implement it from scratch instead of using a kind of an existing tool such as pandas or another programming language such as R, which is kind of even easier for processing these kind of data. And they seem to be able to do the binarization automatically, such as pandas.getDummies, which we'll demonstrate a little bit. But the point of this homework is more on the feature map or data preprocessing part, right? After you process the data, binarize it, convert it to NumPy array, then the rest of the work is just really, really easy. This is because, think about it in the long run. If you go work in a software company, you're asked to do some machine learning task, and chances are that processing the data will cost you 95% of your time. After you've done pre-processing the data, running the machine learning algorithm is only 5% of the time because you can just use scikit-learn or some other toolkit. And as long as your data is in vectorized format, I mean NumPy arrays, then you can just plug in scikit-learn. You just call scikit-learn.svm or call scikit-learn.logistic regression, call scikit-learn. Say random forest or whatever. You can easily switch this machine learning algorithm with another machine learning algorithm. It's very, very easy to do. Okay, and in your real work, you won't be able to implement a machine learning algorithm. You really just use a machine learning algorithm, right? But the data processing, nobody can do it for you, right? You still have to be able to pre-process the data and convert it to NumPy format. Um, in our homework one, the data is already very clean. You don't need to do any cleaning up of the data because the data set looks like income.dev, right? Something like this. Um, so you have many fields, but the data is very, very clean. There are no missing fields, no missing data, and everything is just very, very well formed. In practice, you won't be able to see these data. You'll see much messier, dirtier data, which you need to clean up a little bit. So as a data scientist, you really need to be able to use Python to do these kind of data cleaning up, pre-processing, and feature map yourself. And the accuracy of your prediction depends much more on the feature map or pre-processing the data than the choice of the machine learning algorithm itself. As Michael has noted on the discussion board, if you just change the machine learning algorithms, they almost all perform roughly around the same accuracy of, like, say, 85% of accuracy on this data set, or maybe between 80% and 85%, right? And perceptron is pretty good. Average perceptron is even better. So really, it's the choice of your feature map that matters. Okay, so in homework 2 and homework 3, you'll be dealing with more kind of complicated data set, and your ability to process the data, to convert it to NumPy format, is the key factor in your success if you're a data scientist in the software industry. So think about the long run, right? You need to understand machine learning algorithm, yes, but you also need to understand that machine learning is more about feature processing. Okay. So let's use this example. But this example is still too complicated. Let's use a very simple example just by looking at the first two columns. Okay, so what I can do is I just want the first two columns. So how do I do it? Well, I just want to cut the first two fields. But that doesn't work because you have to specify the delimiter as comma. So that's the first two columns, age and the sector, right? And let's just save the first 10 lines of these first two fields to a very small file called toy.txt. Okay, and now let's start a Jupyter notebook. Toy.txt. Well, no, you cannot do that. You have to say notebook, right? Normally, you wouldn't need this too, but because I have both Python 2 and Python 3 set up, my current default Jupyter is actually Python 3. So in order to use Python 2 Jupyter, I did this Jupyter 2. You don't need to do that. If your default Python is Python 2, then you just say Jupyter Notebook. But because my default is Python 3, I did Jupyter Notebook from this directory. Okay, it starts like IPython Notebook server, and you can see all these files. If you want to look at toy.txt, toy.txt is just like these, right? Now you can new, well, you don't need to new any file, but you can new a Python 2 notebook. Okay. Now we're in the Python 2 notebook. Now you can actually perform some Linux commands such as ls, which means listening to files, and for those you need to use the exclamation mark, right? So right, these are the files, or you can less toy.txt, or you can just cat toy.txt. Okay, that's the two fields of the first 10 lines, first 10 records, in other words. Now let's try to binarize just this very little file, which is easy, right, to demonstrate the point. Let's first look at how pandas does it, okay, just as an example. So import pandas. You don't need to understand these because this is just totally optional. You can use pandas to verify your result, just like you can use scikit-learn to verify your perceptron. But in this homework, at least, you need to be able to implement them from scratch. In the next two homeworks, you might be able to use these tools. Okay, spd and import numpy as np. So these are always the case. And then you can say f is pandas dot read csv, because we have a csv kind of file, toy.txt. What is my f? My f is like this. So pandas is kind of cool that it gives you this kind of a structured format instead of this text format. It gives it kind of Excel-like look of this database. Okay, but what pandas can do more is the binarization, right? So here you use pandas got dummies f. So normally it works, but sometimes it just doesn't work. See, this is another reason why you should, in general, not use pandas, because it's not very stable. It's not very robust. So what I can do is get dummies, which is trying to convert it of one field at a time. So age, let's say. So let's look at fh, for example. F of age. Oh, you cannot look at f of age. Oh, yeah, because we haven't supplied the names, right? So let's do the names. So the names of the fields are age and sector. Now let's reload the file. Reload it with the names. You don't need to understand it. Again, you don't need to understand any of these because this is totally optional stuff. Now you have age and sector, right? Previously, you don't have age and sector. You had 5045 being mistakenly read as the name of the first column, right? So because pandas would by default think of the first line as the header line, a header row. So that this is the kind of the name of the first column. This is the name of the second column, unless you supply a field called names, right? So now you can use f of age, right, now to kind of query the first column, and f of sector to query the second column, right? So name sector d type is object, d type is int 64. So what is the type of fh? It's actually the pandas series. It's not NumPy, okay? It's not NumPy. The job of this tutorial is to convert these guys to NumPy arrays, NumPy vectors, okay? Now what you can do, well, can you do something like f of 0? Unfortunately, you can't. So pandas is sometimes very hard to use. You can use head and tail, right? For first 5 and tail gives you the last 5, stuff like that. Yeah, but pandas in general is not easy to use. So what about pd.getDummies? If yeah, you still cannot get it to work, but you can do it one field at a time. Okay, one column at a time. Okay, so this is the binarization that we wanted, right? So the first person is age 45. So this bit is on. This dimension is on. The second person is age 33. This dimension is on. Every person has one dimension on, and everything else is 0. So that's what we call one hot representation, right? So this is totally binarized. And the nice thing about pandas is that it actually sorts the age, right? It's actually sort every single field. So this is the kind of format that we wanted. And actually the type of this result, very interesting, is already it's data frame, but we can easily convert it to NumPy array. Sorry, I'll do it here. Sorry. Okay, so I'll just convert it to NumPy array. Yeah, we got NumPy array. Okay, and if you want just integer values, you can do it still. The d type is int, so you got the integers, right, instead of floating points, because we're binary features, we're either 0 or 1, so it doesn't make sense to be floating point, but it doesn't matter, right? Okay, that's one thing. And the second column, you can do the same for the second column, which is sector, right? Sector, you only have 3 choices, right? Because if you look at sectors, there are only 3 different values for sector column, either federal government or private sector or local government. Yeah, just the 3 of them, at least in these 10 rows, the first 10 rows. Okay, so you only have 3 features, 3 binary features for that column, right? So each original column becomes many binary features. For example, age becomes like, I don't know how many there, 1, 2, 3, 4, 5, 6, 7, 8, 9 features, and sector becomes 3 features. So in total, you have 9 plus 3, which is 12 binary features. And now, because we have 2 NumPy arrays, we can kind of concatenate them together. We can just kind of concatenate this at the end of this, so we can create a 12-column kind of array. So the way to do it is to, let's call this age, and let's call this sector. So just to simplify it. Okay, and as we talked about last time, we can use numpy.concatenate age and sector, right? That doesn't work. You have to do it with a pair, right? Even that doesn't work. Why? Because by default, it concatenates along the first dimension, the first axis. You're actually concatenating along here, which is kind of vertical concatenation, not like horizontal concatenation, no, not like default concatenation, which is adding stuff at the end. You're adding stuff to the right, not to the below, not adding new rows to the end, to the bottom. You're adding new columns to the right. So you're actually concatenating along the first axis. So axis equals 1. Yeah. Now you got a 12-column representation for the 10 people, the first 10 examples in the data set. Okay, this is the representation that we wanted. Okay, before you can feed it into a machine learning algorithm such as perceptron, such as your own perceptron, such as any scikit-learn machine learning algorithm, such as scikit-learn.svm, scikit-learn.logistic regression. They all require this format, right? So now, so pandas looks like it can do this job, even though it's not super easy. It's not like one button, right? It's kind of 3 buttons. You have to do this, get dummies for one field, get dummies for another field, and then concatenate along axis 1. Okay, if you have many, let's say different columns, you can do it here as well. Okay, that's how pandas does it. And next we'll show how Python does it.